right? Let's continue further. Now, I'd like to find out what is the color of that particular pixel in that image. So for example, I'm trying to see this particular pixel in the image. What is the color of that? Although we have drawn a red line over here, just for your understanding, but ultimately I'm referring to this particular pixel in that image. What actually the color of that image? What is the blue, green, and red color of that image? Because they are not actually pure blue. They have got a mix of blue, little bit of green and red. In that way, they have got a huge resolution of colors. That's why color is so beautiful, because the more resolutions you have, the more channels that you have, the more combinations of colors that you can produce. So what I have done over here, I've just used, because I know that I'm just saying, because the images are already in a BGR format. So the images actually, because I haven't got, you know that image is actually BGR format. When I convert that thing, it's a different scenario. But image that I have already taken is already in the BGR format, right? Blue, green, and red. So I'm saying, get the image of 150 by 150 pixel position. That means my X is 150 and my Y is 150. So that means this particular position, get the blue, green, and red of that particular. So BGR, this is actually a very simple command of, by saying image 150, 150, it will give me the color of that particular pixel, which is in the location of 150 by 150. Okay. And then after that, what I'm doing, I'm just printing that value. This F is actually called a format. How I'm going to print that thing. So this is another way of printing your string. So print F is a format. In a format way, first of all, you print blue, and then you print green, and then you print red. Now this is also another syntax. You don't need to memorize. I mean, you just copy and paste. So this is how you print the value of blue, green, and red. And I've been telling you again and again that we never learn programming. We never learn memorize code. What we do, we try to understand the code so that you can use the code. Everything is open, right? So you can, once you understand the code, you can implement that code. And that's why our exam is also an open book exam, right? So the codes are there. I'll talk about this final exam in the next week, which is very important. But anyway, so blue, green, and red, I just say print. So what will happen to print the value? So the pixel value of that particular blue is 203, green is 198, and red is 221. So this is actually a pixel value. And in this combination, we have generated a pixel over here. So in that way, I can find out each and every individual pixel value in the RGB channel of an image itself. Easily I can see it. And once you start creating it, you can start finding out each and every object, okay? The distribution of the pixel intensity on different objects. Like when I'm talking about C, how the images are, how the pixels are distributed, I can easily find out because I know what is the RGB value of those things, right? So the beauty of working with image processing is that you can directly go to the image value, pixel value. And once you get the pixel value, you can easily play with it. You can change it, modify it according to your own need. You want that C will be different color. The first one will be only red. The second one will be only green, and the third one will be only blue. So you can go to the pixel value, go get the pixel coordinate, and then change that color with red, green, and blue, and you can easily change the color. So C with multicolor, red, green, and blue. So you can do a lot of things like that way. The beauty is that if you can extract the pixel value of that particular pixel in an image, you can play with it. So this is blue 203, green 198, and red 221. So they have different. Now red 221 means, although the color is red, but it is a different color. It's not actually pure red, or not actually something dark red or not light red. There is something in between. So they have a different color shades actually, and in that way, when red, green, and blue combines together, it produces new colors. You know the prism, right? Prism, RGB prism, right? The Venn diagram. I mean, you can draw any color with RGB itself. This is a prism value. So those who done a bit of physics, maybe at the study in the school, they will understand what actually RGB prism is. So you can use RGB to combine any sort of color combination as well. Okay. Anyway, for us now it is a trial and error method. So we just change the color and we see which color looks good. We keep that color. This is how it is working for us. And the whole this type of image processing is also about trial and error method. So we change the values of each and every pixel and see which pixel looks nice, and we get that value correct, and then we go with that one. Okay, now I would like to extract the logo. So this particular logo I would like to extract from there, and the whole logo and charge universe from the image itself. So now what I'm doing, this is called object segmentation, right? What actually segmentation means? A segmentation means that in an image, suppose you have a ball, okay? Then you have suppose you have a stick like this, okay? Then suppose you have a bowl, okay? So there are a number of objects in an image. What you can do, you can segment them or you can crop them. So this is called object segmentation, right? I can crop each and every individual objects from that image by using image processing, and this is called image segmentation. And we do that thing based on bounding box. So we need a bounding box. Look over here, this is actually called a bounding box for us, right? So we need a bounding box strategy which can be used to highlight that particular object, and we can crop that object, or you can take that object out from the image itself. So this is called image segmentation. Now look, if you really want to see your future, especially in the field of data mining, data science, people work with data, and data can be anything. Data can be your signals, okay? It can be your numbers, categorical value, numerical values, or it can be also images. It can be anything. I've seen lots of experts working with image processing. I've seen lots of people working with data processing. I've seen lots of people working with signal processing as well. So there are a number of different types of domain of data that you can use. So image processing is another important field of working, especially especially in diagnosis, in clinical diagnosis as well. It's a very important thing. Anyway, something for you to think about it. Okay, so if you really want to see your career in doing machine learning and data science model, especially, and working with data processing, image can be one of the very strong field for you to work on, or all the other sort of data processing that you're working. They're really, really strong and important. Okay, and keeping in mind, there are lots of codes available basically on image processing. So you just need to download them, modify it according to your own way, and you go from there. Now what I'm doing, I'm trying to extract the logo from the image. So what I have said, extract the logo, I mean this is actually variable, from the image 100 to 155. That means my X will be from 100 to 155 is actually my X, and Y is 30 to 230. So that means if this is Y, so this is 30 to 230 is my Y actually. So this is Y, this is X, and I have to extract that logo from there. So if I see, so this is actually my extraction of that particular bounding box. So I'm defining the bounding box x1 to x2, what will be my x1 and what will be my x2, and y1 to y2, what is my y1, what is my y2. So this is my y1, y2, and this is my x1. So this is called 100 to 150, and this is called 30 to how much? 30 to 230. And then I've created a box like that. And in that way, I'm trying to. Now, again, this type of things, how you do? I mean, usually you don't play trial and error method. For example, if I ask you, for example, if I give you an exam a question in an exam that I want to extract only, suppose this particular box with all the petals, 1, 2, 3, 4, 5, 6, 7 petals that you have. Okay, I want to extract this one in the bounding box. How will you do that? You cannot play a trial and error. Okay, maybe x2 to 200, 1 to 20. You cannot do that. The best way to do that, actually, you extract the information. You hover your mouse on that images, for example, and find out the coordinate of this one, find out the coordinate of this one, and then you just put the coordinate matching and do the coordinate extension, x1 to x2, y1 to y2. In that way, you can do it, right? Because you know each and every individual pixel coordinate as well. This is a very simple thing. So either if it's an image, then you extract all the information of the image itself into a PY file or an NumPy file, and then go to certain location of that particular image of this one, find out the coordinate of that particular Excel value, of that particular value over there, and then you can create it like this. So, and there are already functions and methods that are there also to tell you the coordinates of each and every individual pixel that you have in the image. And then you look for this particular coordinate, for example, in the image, and see what is the coordinate value. And then from there you go up or down, okay, and X and Y, and then create a bounding box for yourself that can fit in this way. So this is another thing actually. In the image processing, we also do a bit of trial and error method. We need to find a bounding box. This is a bit big. Let's make it a little bit small. So I'll go this one. Now let's make it a bit more small like those. So this is our trial and error method. So the way actually you visualize that, how your box will look like and to what extent it will fit. This is something called a vision problem. So you use a vision, you use first of all your human observer, observe the whole thing, and then you train your system to see the same way you are seeing actually. And this is actually how we create a bounding box to extract the images from the original image. Right. Now, so I am saying, now once I've extracted the library, I'm saying that CV2. So I'm using now not PLT because that's why there's no conversion. I'm saying CV2. So that OpenCV library, image show, extracted logo is actually the name of my window, and the extract logo is the logo that I have extracted. So as you can see, this is the logo that I've extracted. Now, as you can see that the bounding box is not quite over here. If you can see over here, I mean, there's a lot of chopping. I mean, the tail gets chopped, right? So there's a bit of chopping. So what you have to do, that's why it's called a trial and error method. So in that case, you just increase the box width board and try to capture all, even T is not there, I think Y is missing as well. Capture all this thing and put it in a nice bounding frame. So this is actually how you play trial and error and then start working on creating the bounding box. Understood, guys? Clear? How about you guys? Understood? How about you guys?
Yes, sir.
Online students, have you understood so far what I have said? Have you understood what I have said so far? Okay, that's a very step-by-step process of. Actually, I thought that I should not teach so many things. You guys should be in a position now that you should see the code by yourself, do some search on Google and everywhere, and then maybe your friend ChatGPT as well, say what is RGB, what is this thing, what is image show, and they'll give you answers, all these sort of things. And then in that way you can learn as well, okay? But anyway, this is in my habit actually. I love to teach, show the codes, but it is important that you should also do it bit from your side. Anyway, so this is actually output, but anyway, I'll give you some tutorial for you to do it for yourself. That is important, but I'll show you how to do that. Now, let's start with something called operations, bitwise operation. What actually bitwise operation means? Because you know that I have told you that in the image, everything is a bit, right? One pixel means 1 bit, right? One block, 1 bit. Now, this bit can have 1 value, or it can have 3 values. If it is a color, then 3 values. If it is grayscale or black and white, you have only 1 value. So what I'm doing, I'm trying to create some AND operation on 2 images. So this is called one image. I have created one image like this, which is half is black, half is white, half is black. And another image with actually whole black, and we have a circle as white in there. Okay. So that is there. Now I'm going to do a bitwise AND operation. What actually bitwise AND operation? You know what is the AND operation, right? I mean, this is simple. AND means that when both of them are true, then output is also true. That is AND operation, right? So if I say 0 0, it's a 0, 0 0 0 1 0, 1 0 0 1 1, then only 1. Yes or no? That's the thing actually how it works. Now, for example, if I do an AND operation with these two, that means each and every individual bit that I can see over here, if I do an AND operation, how the final picture will look like? This will look like this. Do you think is it true or false? Do they look like this? Do you think? Yes or no? Just look into it side by side, right? It's an AND operation. So if I see this is suppose 1, this is 0. So 1 and 0 actually will give me 0. So that means it's black. So all these things, wherever they're black and white, they're combining 1 and 0, 1 and 0, 1 and 0, they'll be all black. There's only one portion where the white is. Why? If I just make it half, this white portion and this white portion is 1 and 1. Yes or no? So this 1 and 1 will only give me this one. And all the other things are black. Clear? Now these things, if I give you an example, that I give you a couple of images and say they do a bitwise operation and everything, how your final figure would look like, you have to draw a figure like this. Yes, but anyway, I mean, your exam question will not be so easy like that, but I'm saying that this type of things can be there just for your understanding, you know. So bitwise operations, just multiplication. Anyway, that's there. So how I do that thing? How actually I do that thing? What I have done, I have got two images, image 1 and image 2 over here. So this is image 1 and image 2. I'm saying I'm using again the CV2 library. I'm using the method called bitwise underscore and. So this is actually a built-in method. So I'm doing the AND operation on a bitwise based on two images, image 1 and image 2. Mask is none. So what is masking is? Masking is something that you will understand a bit later. Masking is something that you want to do operation based on certain mask or certain region, for example. So I got a region, suppose, think in this way. I'll just tell you what actually masks look like. And it is easy for me to explain from medical terminology. Let me show you. This is not complex, but maybe it will interest you in the future so that you can come and work with me as well. You never know. I'm currently working with something called lung infection. Okay, so children's having bronchitis, lung pneumonia, and then they have a lot of lung infections in their lungs. These are all kids, small kids, very sensitive data, very So they're doing CT scans, and I know actually how hard they are actually. So one of the problem is that what actually happens, your lung look like this. Okay, so if you see the CT scans, you'll see this is called right lung, but also according to it shows left lung. But if you see it's actually from the children's chest, so this is called right lung. This is called left lung. Okay, right lung and left lung. And this is called a CT scan of a particular kid of that thing. Now, my duty is, one of my work is to look into the infections in the lung region only. All the other things are pretty much, we have heart at the back, we have the whole body, chest, and everything is there. So we'd like to see anything from the lung region itself. Now, in order to do that, what I have to do, I have to extract this lung region from the image, right? I have to extract that lung region from that image itself because it's a whole CT scan. So what I do that, so this is called masking. So I will try to do something called masking, and I'll create some sort of masking images that will be multiplied with this one, and it will look only for this shape from the lung, and it will extract the images outside. In that way, what I'm doing, I'm cleaning the lungs with all the other remaining things to get rid, and I'm just getting the left and the right lung. This is called masking. Looking for an object of a similar shape that I have defined in my mask, and I'm using that mask to look for that, to extract that lung region from that CT scan itself. Then once I get that thing, that means I have only this particular right lung and left lung, and then I can work on that for further analysis. That is there. So this is called masking, right? So that's what is called image segmentation as well. So that's a so important thing. Like CT scans have got this type of a lot of things over here. So and they're quite complex as well, but they're also very rewarding. When I see outputs that I can start finding the infections, it's very rewarding as well, But anyway, so that is actually what is called masking called. So you use a certain shape, look for that shape into the main image, and once the shape is fulfilled, then you extract the image. That is called masking. And that is actually called the process of segmentation. So you use masking to segment a particular region of interest from the images. Anyway, this is beyond the scope of your study, okay? But concentrate. These type of things you'll learn in the future, okay? Study is not about only passing grades and getting grades and finish up your semester and done. Study is about learning new things as well, okay? And then implement that thing in the future. And I really want all of you to come up with something really good. Anyway, so this is actually called a bitwise AND operation, doing an operation and getting some sort of and some sort of new images based on AND operation. Let's continue further. So this is actually code. So image 1, image 2, then destination image cv2.bitwise image 1, image 2 marks none. Then I am saying image show with that new image and wait key, and then this will actually display that one. So the code is below and the output is at the top. So this is actually a code, very simple code, you can see easily. You understand that how to read the images, There are two images. Now it's called PNG. So you can see that CV2 actually can read JPG, PNG, JPEG, any sort of images that you can think of. So PNG, JPG. There are other sort of different images like DICOM that you cannot do with CV2. So there are other files, but JPG, PNG, JPEG, this type of images you can use CV2.imread, and then you can easily read that thing. So I have used image 1 and image 2. I have done the bitwise AND operation on those images with no masking. So there's no masking over here. And then I just plot that with the window name as bitwise AND, and then I'm waiting with a wait case 0. Right. Now, there's another one which is called XOR, exclusive OR, and OR, NOR, right? Exclusive OR also is another one. This is actually another one that we say. Now, exclusive OR actually works in this way that if both the values are actually, it will mark the pixel with which both have same value as black and has different value as white. Now, if I see over here, this is white, this is black. So when both the values are different, then it will come up as a white. This is called XOR. So when both the values, suppose 1 and 0, then output will be 1. Or 0 and 1, output will be 1. All the other remaining one, which is 1 and 1, or 0 and 0, they will be all 0. This is actually how it works. So when both of them are different, it will be always output will be 1. And when both of them are same, the output will be 0. This is called XOR, exclusive OR. So if you see this and this, when they color together, all of them has changed. This particular bit, which is called white, and this particular bit is called white, because both of them are same. So that's why it will be converted to black, and all the other things will begin. And this one is black, and this one is white, so that will be converted as white, and all the regions are white as well. So this is called an XOR function of converting. This is a basic truth table. You don't need to memorize that thing. You can just use that XOR table to see how you can convert the image XOR. Like the last one is the AND operation. This is the XOR operations, and we can do it. Same goes with same thing. Destination CV2.bitwise XOR image 1, image 2, marks equals to none. And then again, it's a bit of practice for you to see actually how it has been changed, but it's very simple. I already showed you what is happening over here. Okay. So this is another sort of XOR operation that we can do images, and then we can get a new image over there. And this is actually the code, same code. Again, all these codes are there already in the online. You can download them. Even all the images are there as well. So you just need to download them, put them into the directory, and call them using these functions, and you can easily convert them and do that as well. Okay. So that is actually how it is working. XOR image 1, image 2, marks equals to none, bitwise and destination and wait key. This is a fairly an easy tasks that we are working on. I'm just trying to make you understand all these codes to get yourself familiarized with these codes, and you practice. But definitely, if you're really looking for something good in the IT code fair as well, building applications with images and everything, this is a very important tool for us to learn so that you can practice them. Now, I will also show something which is called age detection. What actually age detection means? And age detection means is actually something that each and every images has got an ages, right? Like for example, if I show you over here, think about this one. So this is age, this is age, this is age. So everything has got an age, right? So this is called age. So I would like to see all the age detections of a particular image. Why you do for age detection? Because with the age detection, we can detect the shape of an object, right? For example, if I'm looking for a heart, okay, so if I know the age, of that heart, then I can easily claim that this is a heart, right? If I'm looking for a ball, how can I say it is a ball? Because looking at the age, yes or no? So this age will tell me it's a ball. If I'm looking for a triangle, so that means this age will tell me my triangles. That's what age detection. So age detection is actually one of the important tools to identify the shape of the object, right? So what we have done over here, I've showed over here. There's a tool that we're using. There's a library which is called Canny Age. Canny is a very important age detection technique. What I'm doing, I'm just looking for all the ages of that particular image, which is called CDO logo. Height is 100 and width is 200. So there's a window that I have created. Look for all the images in that one, and then you show it with the tool name as age detections. So once I go there, look, all the ages are showing over here. So this is the height is 100, and the width is 100, the height is 200. Okay, and then all under this width and height of the window, look, these are all ages, right? These are all ages actually. So this is not actually filled in, there's no color, this is age. So now I can say, looking into the age like this, I can say this is C. Looking into the age like this, I can say this is D. So this is actually age detection. So the difference between this one, this particular age picture, and this picture, you can easily see. This is actually, they have an age, but these are all filled in with colors, right? So you're not extracting the age. Now, if it is a filled in like this is, hold on. So this is called an object with the colors filled in, and this is called an object with no color, just looking into the age of that particular object. So this is called age detection, and age detection is very, very important actually. Okay, you can use this type of age detection technique to find the roads, maps, and everything in the outback season as well. Okay, you can use this age detection to find, what is that called? There is one of my students who work with video surveillance actually. So one of my tutor, Mahmoud, actually, he worked with me in that thing. We are doing some live video streaming, and then we're looking for sharp objects like pen, knife. Okay, so this is some sort of video surveillance that we have done. Are there any weapons or something that is really harmful? And how to do that? Look for those type of ages, and then try to see that whether that age represents any sort of sharp object or not. How can you do it? Based on age detection, right? So this is Canny age. It can be used for surveilling this type of objects as well. One of the methods that we can use. There are a number of methods there, but this is one of the methods that we can use for age detection. Okay, let's see. So let me ask my online students. Have you understood so far with the age detection as well what I have mentioned, and even the bitwise and bitwise XOR? Was that clear to all of you? Good. Couple of more. Only two of you have understood. No one more. Good. Okay, that's fine. So that means I'm still with you all, which is good, So this is called age detection technique that we've used. Now I'll go to the tutorial section now. So this is pretty much a whole bit of what is that called, an age detection technique. Okay, let me stop this recording.